Welcome back to our series of solution and explanation to competitive coding. Today we are going to solve LeetCode question number 744, that is find smallest letter greater than target. So let us understand the question first. So the question says that given a character array letters that is sorted in non-decreasing order and a character target, return the smallest character in the array that is larger than target. So we are basically given a character array of characters, that is letters, that is sorted in ascending order. It means non-descending order means it is sorted in ascending order, and a character target, and we are given a target character written the smallest character in the array that is larger than target. So in this question, we don't have to return the target element. We have to return the element that is like greater than target element. That is the smallest element greater than the target element. And we are given a note. Notice that the letters wrap around. So what does it means is that in the example we have given, if target is equals z or z and the letters are like a and b, the answer is A. What it is trying to say is that suppose if the Z is present in the array, so for a sorted array it would be something like here, to be a sorted array if that is present in the array. So we have to return the next element or the largest element that is in the array. So there isn't any character that is like greater than Z, so we have to roll back to like 0 index and we have to return A. So let us see what our examples say. So if suppose in our example number 1, if the letters our array is like it holds character C, F, and J, and our target is A. So if A would be present in our array, so it would be something like here. So we have to return the next largest, like smallest element larger to the target or greater to the target. So if A would be something here, so we have to return C because C is the next element which is like greater than target and the smallest element in the array. So the output is C. Suppose if our target is C in the same array, so if this is our target, so we have to return the next smallest element that is greater than target, that is greater than C. So it is F basically. And suppose if our target is D, so if D would be present in our array, it would be something like here. So we have to again return our like F as an output. So let us understand and so that how can we solve this question. So the most basic or like brute force approach would be, suppose if this is our example array and if target is like F, so if our target element is F, so we have to return the element that is greater than the target element and smallest in the array. So in this array, if F would be present, it would be something like here. So the elements that are greater than F are all these elements, that is from here to here, and we have to return the smallest element, that is we have to return H. So the most basic or brute force approach would be we should start iterating over the array from the 0th index and check if it is greater than or equal to F. We found that this is smaller than F, then we keep on moving moving for our search. We found that next element is also smaller, then we move forward and check if it is greater than or equal. If it is equal, we move forward and return element, but in this case it is larger, so we can return our H as an output. For the next element, what we can do is that we start iterating over the array, and we found that this element is equal to our target element, and then we can return our next element, that is we can return our S as an output. And for the last example, or for the last target number 3, for Z element, we start iterating from 0th index and we keep on iterating a whole array, and we found that our target isn't found, and if its target would exist, it would be something like after the length of array or something here. Then we know that if our target would be here, then we'd have to return the element that is greater than, and there wouldn't be any element that is greater than our target. So we have to roll back to our 0th position and we have to return our B as an output. So this is the most basic or brute force approach that we can apply, but our question holds the hint for our solution. That is, whenever we found that our array or whatever the data structure, if it is sorted and we have to find for something, we can use binary search for our optimal solution. So I think so. Binary search would do great for us. So let's see how would binary search would work if this is our case. So suppose we are searching for our element. So if for in a brute force or in our linear search approach, it would take something like 1, 2, 3, 4, 5, 6, and 7 steps to reach our. So to reach S, we want 7 steps, and to return, we have like one extra step to move forward and return our target, like ceiling element or seal element. So if we did the same with the help of binary search, so what binary search says that we start in our binary search, we set up our two pointers like end, like start and end pointers. So this is our start pointer to our starting of the array and our end pointer to the end of array, and we check we compute middle each time by adding start and end and dividing it by 2. So our middle would be something, for this case our third position element would be our middle element, so this would be our middle, and we check if the middle element is like greater than or less than target. If it is like greater than target, then we discard the upper half array, and if it is like in this case less than, like in this case our middle element, our target element is like greater than our middle element, or our middle element is less than our target element, so what we'll do is we'll discard of our initial or smaller half array, and we'll work only on our larger half array, and we'll move our start element from here to middle plus 1, and our like half of array is discarded, so our work will decrease exponentially, and our time to search for the element will be logarithmic. So in the next step, our middle will be something like here, and we found that our middle element is equal to our target element, so we can now return our next element. So it takes 3 steps instead of 7 steps, so it reduces our work in exponential time to log, like if initially we are taking logarithmic time to and now initially we are taking our linear time, and by the help of binary search we can reduce it to logarithmic time. So let us code our solution so that check to if it works or not. So to code, we have to initially set our two pointers, that is start and end. So we can do is that int start equals 0 initially, and our end would be something like letters dot length minus 1, I can say. Yeah, that is letters are our array or character array. Okay, so our pointers are set. Now what we can do is we can do our while loop, that is while our start is less than or equal to our end, we can iterate over and we check. Now in this we have to compute our middle element, that is int mid, and it would be something like start plus our start end minus start, and then we can do our divide by 2 and minus start to handle the situation of array index out of bounds, and we can check if our target element is less than letters of mid. If it is less, we can do is that we have to move our end. Okay, so our end would be updated from like last position to mid minus 1, we can say, because our target is smaller and our end is like far away at the end of the array. But if the case is opposite, that is if our target is like greater than letters of mid, then what we can do is that in the else case we have to move our start would become mid plus 1, and in the end what we can do is we can return our element. So the situation is that we don't have to return the target element, we have to return the element that is greater than target. So suppose in this case, if our R is target and we are in the at this position, like, and is in the 5th position, so eventually our start and end would move to this position. Suppose something there is like suppose if there is some, we have to find for t elements. So what would happen that our mid start and all would be here, finally they will move here, our mid our start and our end all would move here, and we found that our element is not found. And to break the loop, our start would move ahead, and the situation will our loop will be break because we met the condition that is start we should always be less than or equals to end to continue in the while loop. So if we break the loop, that means starts move ahead of end, and we have to return that element because our target is t. Suppose in this example, if our target is t, so we don't have to return t, we have to return the next element that is present in the array. So our start is already moved here to break the condition of the loop, so we can return our start. Okay, so we can return our start. Letters of the start, letters of start. But we can't do this at all, like for all, because we have a condition that the letters wrap around. So suppose in this situation, if our z is present here and we have to return our b, so what we have to do is that if our start, if finally our like mid start and end would be here at the last element, so to break the condition, our start would move something like here. And if we move here, so to break the to return to the zeroth index, we have to do something modulo length of the array, the start modulo length of array to get the zeroth index. Okay, so we will do the same. We'll not only return like the start element, we'll return start modulo letters dot length. Okay, so I think it should work now. Let me check if it works or not. Yeah, it did work. Let me try one or two other cases. Yeah, this one is like for a element, like this one. If we have something like d, let me check for c if it works or not. Other test cases. Okay. Now let me check for one more test case, that is for L. Oh my bad. J. If our target element is like greater than our last element, then is it returning the correct answer or not? Yeah, it did work. So let me submit a code to check its optimality. It did work, though I don't think so we use much of memory it is using, and it is not pretty much faster, though we use a binary search. Let me submit it again to check if it is stable or not. So now it's showing it is like 100% faster, but it uses memory. We use some of pointers, I think, so that is the memory only we use. So hope you enjoy learning, and if you have better solution or approach, you can comment in the comment section down below. And as always, thanks for watching.